One of the applications of using trigonometry is to use solve problems that involve bearings. Now, these are real life situations because people, if they're doing any navigation, will use trigonometry to actually work out distances and depending on their bearings they're taking and which direction they're heading in. So there's two ways to look at direction in terms of our problems. The first one we don't see very often is our compass bearing. So if you can see, we always have north up the top. North, no matter whether it's compass bearings, compass or true bearings, north is up the top. So that means south is down the bottom because it's opposite of north. East is to the right hand side there, and west is to the left. So there's the four main compass bearings. Now we do have other ones. So right in the middle of each of those, if we have a look at the ones that are there. Now this one we call northeast because we always read the vertical axis first when we're talking about the compass. So either north or south. So and then whichever side we go to is the one in the middle. So we go up to the north and halfway across to the east there, and then or if we go down here down to the south and then across to southeast. So southeast is halfway between south and east. Southwest halfway between those two, and northwest halfway between those. The other one that gives us 16 all up is when we get halfway again between those two. So if I go to northwest, so I go north and then to the west, and then I'm going to add another one. So I'm going to say this one here would be north-northwest because it's halfway between north and west. So it's north of northwest, so it's halfway there. This one would be west-northwest, so it's halfway between west and northwest. So you can see where we get the other ones from. We split into 4 with the major axes, then we split into 8 with the other one, the next lot, and then 16 when we go in between there. So going to the south and across to southeast, but back to south would be south-southeast. And if we go south, southeast, and then east of southeast would give us that one, east-southeast. So there's our 16 compass bearings there. The ones we're mainly going to use, though, are ones where we use an actual degree there. So in the what we call bearings or true bearings, we signify north again. North is the one up the axis at the top. That's also what we're going to call 0 degrees. Now, a lot of times our bearings, we label them with 3 because we go right round 360 degrees. So we often have them labeled at 0 degree, 0, 0, 0 there. So if we have a point here that might be an angle that goes across 30 degrees, the actual point here, we would not say it's at 30 degrees, but 030 degrees. It just aids in not being able to, it stops us from having some misinterpretations, but allows us to, if we hear 3 digits, we're able to get any of those 3 digits in any of the spots. So east here would be 090 degrees, south would be 180, and west would be 270. So any direction we want to go in, we can go and label that. So if we have a point over here and we've gone, say, 260 degrees there, this bearing would be 260 degrees. So that means that angle there would be 10 degrees. We get to do a little bit of adding, subtracting. So if we have a point here that goes on, say, 25 degrees on from 270 degrees, then this point here we'll be saying would be 295 degrees. And it goes all the way back to 360, goes 360 degrees because it's a circle. We don't really say 360 because that's identified by 000, but really around to 359. So some of the language we're going to involve with here as well, we've got to be really careful of. So if I've got a point A there, and that's in the middle of those axes, and this point B here would be in the middle of these axes. If I was looking at the bearing of B from A, I'm actually looking straight down this line. We're trying to get it nice and straight, not too bad. But what would this bearing be? So I'm going to be looking at that being the bearing there. So say this angle here would be 20 degrees. So the bearing of B from A there, we would say would be 110 or 110 degrees. So we're looking at, basically imagine if you're standing at A and you're looking at B, because we're looking at what the bearing from B of B is from A. So we've got to be really careful of that of and from when we're looking at when using the language here. So if that's 20 degrees there, because these are all parallel, that would be 20 degrees there. So if we're looking at the bearing of A from B, then we'd have to go all the way around to that point there. And because we know that's 270, so 270 plus 20, the bearing of A from B then would be 290 degrees. So be careful of our language. So, as we said, the bearing of A and from B. So that of and from, we often get that language mixed up. So we've got to be really careful when we read that in problems. So of B, the bearing of A of B from A was 110, 110, and the bearing of A from B would be 290, because that's the direction you're looking at A if you're standing at B.